Hello, keyboard enthusiasts or manufacturing enthusiasts. I guess we cover both camps here, or just old machine enthusiasts. I'm Tony Aiuto here in New York. Today we have Joe Strandberg talking with us about his journey to bring the Model F keyboard back from beyond. I go way back with that keyboard. In 1982, I bought an IBM PC, an original model, had the most wonderful keyboard in the world. I'd be on the phone and I was living with my parents at the time. I'd be in a spare bedroom doing work, and I'd be on the phone with my girlfriend at the time, who's now my wife. And she used to call it the electric chicken, because she'd hear the clickety clack of the thing and it'd go, "You're playing with a chicken again." and so it was called the electric chicken from her point of view. I still have my original keyboard. And when I found out about Joe's project, Model F Keyboards, modelfkeyboards.com, right? I went out, though I needed this like a hole in the head, bought this very expensive keyboard, which is gorgeous. And it's in full metal. It's like 6-something pounds. Yeah, you can use it for combat after a day of programming. But I really don't want to hear me. I'm sure you don't want to hear me. You want to hear Joe talk. So Joe Strandberg, a pleasure to have you here. And he'll be talking about his journey. Okay,
so we got this. Okay, well, thank you so much to Tony and to Google for inviting and hosting my talk on the journey to bring back the new Model F keyboard. So now Tony is controlling all the slides. So let's go to the next slide here. So, okay, so the topics that I want to cover today, these are the 11 topics. It's a mix of the project and inspiring people to pursue their own projects in the world of physical hardware manufacturing. And also at the end, we're going to have a Q&A, or do people ask the questions, like, can they type it at any time? Or
so I'm presenting, so it'll be hard to answer in chat. Save them up for the end, but just do questions in sidebar chat, and we'll try to answer them as I can see them.
Okay, and I guess they heard you from that. So the first topic is an overview of the Model F and why people should be interested in it, why people who use their keyboards the whole day, such as software engineers and writers and people who just do a lot of typing, people writing a lot of emails, why they should use a Model F instead of the keyboard that came with their computer or with their laptop keyboard. But maybe not so much in an open office, because these keyboards, as Tony mentioned, are quite loud. So this is a unique project to bring back the best keyboard ever, 25 years after IBM stopped making them in mass production in the 1980s. So the keyboard switch, you can see there's the prototype switch, courtesy of the inventor of the switch, who invented it and was an IBM employee in the 1970s and invented the buckling spring switch. So the keyboard switch has a delicate yet incredibly tactile response that makes typing a pure pleasure. I don't know, how many of you folks have ever gotten to type on one of these keyboards? So not too many yet, but hopefully more in the future. So if you're new to mechanical, or any of you folks, have you ever used like mechanical keyboards before, like the Cherry MX and those type? Yeah, I'm seeing some head nodding. That's good. So if you're new to mechanical keyboards, the buckling spring switch is what many other switches are compared against, but you don't see too many of them because they are not individual switches that you can put onto a keyboard. You have to kind of build everything from scratch, and no one else has done this before this project to get these switches. So that's why you've probably never seen a Model F for sale in any store. So what is the technology? Actually, on your phones, when you're using a touch screen on your phone, that's a capacitive screen. So these keyboards use something called a capacitive sensing technology. So everything is completely sealed, and based on the row and column combination that a key presses, that sends a signal to the computer to send that key press. And unlike a Cherry MX switch or something else where there's a physical metal-to-metal contact inside that switch, in the Model F keyboard, everything is completely sealed. So that circuit board over there is not likely to rust and cause problems in the future. That's why these keyboards are known for their longevity. Many people, and probably the keyboard you bought in 1982,
Works great.
yeah, it still works today because these keyboards were so well built. So that's one of the main draws to these keyboards. It's not something that if it breaks, there's no way to fix it and you have to toss it. With these keyboards, they're easily repairable. You can take apart the whole keyboard. If a spring is broken, you can fix it. If a key is bad, you can switch it with another key. So there's a lot of repairability, very easy to repair once you study it and read a little bit about these keyboards. Okay, and yeah, you got the dedicated following. And the other thing that's interesting is the mechanical keyboard hobby. I don't know how many of you folks are contributors on sites like forums like Deskauthority, GeekHack, Reddit's Mechanical Keyboards Forum. Any of you? Yeah, I see a couple nods here of people on the forums. So that's where I got to hear and learn a lot about these keyboards on the forums, learning from fellow community members about how these keyboards worked and what was so good about them. And of course, you have some downsides. The first thing is that IBM knew how to build things, as they say. I think the phrase is IBM was able to build these keyboards and like anything they built, up to a standard and not down to a price point. And I think that's why IBM spared no expense with making these keyboards. What keyboards today would sell for $600 as part of a mainstream keyboard like the Model F? So I guess back in the day when the keyboard would sell for, when the computer system would sell for an inflation adjusted like $5,000, a $600 keyboard doesn't make much of a difference maybe. That's what the thinking. Yeah. But nowadays, of course, you could buy the whole Chromebook for less than $600. So the market's definitely changed. And that brings us to how the Model M keyboard, and are any of you familiar with the Model M keyboard? Yes, I see a few nods. So the Model M was actually IBM's effort to cut 2/3 of the cost out of the Model F to make it more in line with the plummeting prices of computer equipment in the 1980s. So the Model M replaced much of the metal in the Model F with plastic. That's why Model F might weigh 8 or 9 pounds, whereas a Model M might weigh only 4 or 5 pounds. So the problem with the Model M is that a lot of the plastic, a lot of the metal was replaced with plastic. So you got plastic, and instead of, and I have some keyboards I can show later on, but instead of these two metal sandwich plates like interlocking to each other that can easily be taken apart and cleaned and put together, the Model M, you can't actually fix it once these, because it's all attached by plastic rivets. So they're not as easily repairable as the Model F. Okay, so now on to the next slide. So the project status slide. So this project is a project that's brought $2.1 million in orders so far, and 99% of the 3,900 plus keyboards have already shipped, and I still have about 50 or so left. I was very honored to be interviewed on the radio with NPR on their All Things Considered program, and also interviewed by a couple news magazines, and also the project was reviewed by various YouTubers. So that was a great honor for the project. Okay, now on to the next slide. Okay, so here's a little video of me on the first family computer. So that's really where I got the first exposure to Model F keyboards. My dad was actually taping. This is the very first time I touched a Model F keyboard, and he happened to get it on video. So I wasn't doing too much computing, but it was a nice touch to be able to get that memory on video. So from a young age, I've always been interested in entrepreneurship, making things, taking them apart, often not knowing how to be able to put them back together again in the first place. So that's the start of my journey. I kind of went away from, obviously not remembering my Model F days back when I was very young. The family moved on to another computer, and I began getting back into these keyboards as a hobby in 2013. I was collecting these old keyboards from IBM and taking them apart to clean and restore them and seeing how they work, because I was interested in that kind of stuff. and also converting them so that I could use them with modern day computers, which isn't too easy with some of these models. Some of them you can attach a converter and just plug it right in and you don't have to worry about it. But some other Model F keyboards, in fact, most of them, you had to desolder the printed circuit board and custom make a PCB to be able to use these keyboards with a USB connection on a modern computer. So they were far more involved than most people would be willing to work on to get these going. Okay, so next up we have what developments led to the Model F project. So the Altair 8800 moment, I hope many of you know what that is if you're following the old computer history, but the moment for this project was the invention of the first open source, fully programmable replacement controller for the old IBM keyboards. And this one person named Xwhatsit, who was a contributor on the mechanical keyboard forums, he put together the PCB hardware that he designed, he put together the GUI configuration software, and he did the firmware. All this one person, a single solution that you can use to get these keyboards working on modern computers. Before that, a lot of people were buying them, and there were efforts to convert them, but people were mostly keeping them maybe as display pieces for some of these keyboards. So I mentioned on the last slide, I got a network of IT recycler contacts that I used to help find many of these great old keyboards. And I got a bunch of these keyboards that needed a controller. So what I did was I worked with Xwhatsit to bring these controllers to mass factory production, and I was the first one to do that. So our first batch, not knowing how much demand there would be, we made all of 50 controllers, and we thought, I don't know if that might be too much, we might not sell all of them. So the controller was by far the most difficult part of getting these Model F keyboards working. And then after that, I kind of realized that the other parts are just plastic and metal, and they could be brought back into production. I thought, how hard could it be? Might take a few months. So that was my naivete in thinking that this project might take maybe a few months, and then it would be done. So I was seeing an ever-growing demand for these keyboards against a non-existent supply. So I began looking into the manufacturing challenges. And was the project possible? And if it was possible, was it feasible? So then I began talking and looking into what models to recreate. So a lot of people may think, why recreate these tiny little models when most people use a full-size keyboard? So what was the reason behind that? So it was a combination of several factors. The first one is my own need to my set. I had 3 of the 4 keyboards, and I never could find one of the 4, the 62-key keyboard. So I wanted to complete the set. That was one reason. Another reason was about what the market was like. So back in the day, there were still a lot of recyclers that had really old inventory, and you were able to find these keyboards plentifully, the bigger size models, but you couldn't at all find the smaller models. They almost were non-existent. So a lot of people would only be able to turn to Cherry MX and other mechanical keyboards for the 60% and 75% formats that a lot of people like to use. So that was mainly of the other reasons. And now I want to tell you a distressing story. Some of you may not believe this, but a whole batch of these ultra rare keyboards, which were used at bank branches in the 1980s. So many of you, if your parents were conducting a transaction, withdrawing money or making a deposit, and went to a bank branch in the 1980s, one of these keyboards, the teller might have been using. So these bank machines were eventually replaced, and some banks held on to them. But most distressingly, a whole batch of some of these ultra rare keyboards being stored at a bank, the bank, rather than trying to sell them to an IT recycler, part of the keyboard community, he decided to put all of them in the grinder. So these priceless keyboards, I could see some people wincing here, these priceless keyboards were completely destroyed, and that would have been and that was one of the factors that led me to say, let's try to bring these keyboards back and try to make as many of them as possible so that as many people as possible will be able to use these old keyboards and to be able to buy them. And also the last reason was that a lot of people at the time weren't aware of the difference between a Model F and a Model M. because they're both buckling spring. So the full-size buckling spring Model Ms at the time were available for a fraction of the cost of the Model F. So my thinking was like, are enough people willing to buy a model that is maybe 50% similar to a model that's available for far less? So that's where I decided to focus on the 62 and 77 key models. The next part is about meeting the engineering challenge. So what did I have to do to get this project going? So teaching myself how to do CAD, trace all the parts with a micrometer, and redraw all the parts. The other part is, what is the project philosophy? So my philosophy was that I don't want to fix what's not broken. So faithfully recreating these keyboards without tinkering or altering anything. The only major change was to make sure that the keyboards were native USB. So we didn't use IBM's old controllers or anything. Everything was taken from the patents and the public information then. And obviously the patents expired long ago in the buckling spring. So generics, it was possible to get them, but I don't think anyone else has done a Model F project before this one. So we had to talk with, I was honored to speak with a lot of very smart engineers, PCB designers, and product designers, and also an original Model F factory production supervisor. So this is the guy who was able to tell me all the different specs for the project and how things were done. So actually the original plastic material brand part number was one that was used for the new keys. So we got everything down to all the different specs, the number of turns on the springs, everything had to be original. That was the goal, an exact reproduction. So even I circled a part here, the end of the spring had to be between the 12 and 1 o'clock position, or otherwise you would have problems. So that was just an example of how specific you had to be for making sure that these keyboards worked. And I would have never figured that out on my own, even just by looking at it. So I was really, a lot of people were very helpful in getting the project up and running. Okay, now on to the next slide. So now I want to talk about how to create your own product. So has anyone here done a hardware project? So a couple hands here. I can't see the hands of everyone. Oh, there's a.
Yeah,
I can't see.
You get thumbs up in the chat. I mean.
Oh, you're seeing the chat.
Yeah.
Okay, so I'll talk briefly about this. So here are the steps on how to create your own project. So the first step is you need to either design the product yourself or hire a designer. And that's pretty obvious. But the next part is not as obvious, for me at least. So for finding factories. So a lot of people think that there's one factory that might make everything for your product at the best price and quality, kind of like a general factory. They might be out there, but that was not so for this project. Many great factories for this project were very difficult to find. They might have not had a website. They might have not been on Alibaba. So they were tricky to find. People willing to learn, factories willing to learn how to do all of these, learn how to remake and all these, getting all these processes done. And sometimes one factory that you liked would recommend another factory. So it's kind of like a word of mouth thing too. But for beginners, what I would recommend is working through Alibaba and limiting your choices to those offering this program called Alibaba Trade Assurance. So that's like kind of it gives you some protection and some confidence when you're working with a supplier that they'll make parts that are actually good parts for your project. Okay. And of course, there are tons of articles and videos on how to work with factories on Alibaba, so I'll skip that part. The next part is an interesting part on what you're getting quotes for and how to get quotes. So the first thing is, I'm going to show you a couple slides coming up, but there are so many molds and tooling that you might not even imagine would be needed for your project. So you want to think about all the potential accessories and tooling that you'll need. The big thing that I found helpful is by sharing actual photos of what you're looking for with the suppliers. Like, for example, I may specify textured powder coating finish, and there are a lot of textures out there, so sending them a picture is helpful. Okay. So for some of them, many suppliers will say, yes, 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 we can do it, but then you show them the pictures and they say, oh no, we can't do that. So pictures are very helpful to making sure that you don't commit to a supplier that can't actually do the work you're trying to do. Okay. So I think a good supplier candidate will actually share photos of finishes and other parts they've done within the past and maybe send you samples. Okay, the other thing is you want to balance your production expectations with the cost for the molds versus the cost of each part. So it might be better in the long run for a higher mold cost and a lower part cost, so that if your product gets popular, when you're doing the second round, you're not paying nearly as much as with a supplier that might have offered you a lower total cost or maybe a lower mold cost and a higher per part cost. So it's not always the total cost that's most important with the quotations. And the last part was the interest form. So I think that the interest form is probably one of the most important parts that you want to do with your project. You can't just think like if you build it, they will come, kind of. So with the interest form, and Google Forms is a great resource for this that I use personally for the project. You want to calculate and specifically mention in the interest form the expected sale price and maybe the quantity you would need to proceed with the project. And then you can compare that with the factory's minimum order quantity requirement. Okay, so initially I was hoping to make maybe 100 or 200 keyboards. And now we're up to 4,000. So it's really like no one expected this to be what it was. But also the other thing is you want to expect that a lot of people in your interest form may not actually go ahead with joining your project. In my example, I think about 40% of people who signed didn't actually buy something. So you want to have a much bigger margin than you would think. It's not like a 10%.
Did you make it up with late buyers?
What I did was I just went ahead and said, I'm doing this for 100. And so what I did was I got the quotes for 100 units, and that was acceptable to me. And I got about 250 signups. So I didn't know how many people would actually say yes, but because I got about 250 signups and about 100 units for the quotation, I was able to determine that the economics would work out for the project. And then the last part is just about being a part of the various communities with interests you share that are also related to your project idea, because there's nothing better than being able to be in a discussion with these people. Back in the day, you might have to hire a bunch of experts, and today with the communities, it's you get so much broader base of people interested that can help you with your project because they want to see the product brought to life.
I was just wondering, what forums were you using at the time for this project?
Oh yeah, so the forums for the mechanical keyboards are Deskthority, Geekhack, and then there's one on Reddit called Reddit/mechanical keyboards. So those were the three, and now there are much more. So those were the three that were really the top ones that I was talking with and posting on. So now, question?
Another question. So I also did some projects on like ARM mechanical keyboard, and I found that
Oh, cool.
don't really like unfinished projects. Like if you ask for feedback, it's quite quiet if you just put something like in process. I don't know if you have encountered that before.
Yeah, so that's actually my next sentence here is answering your question here. So that's exactly right, that people don't want to have something where you don't know the qualifications of the person, you don't know if the product is actually going to be brought to life. So my next sentence here, perfect timing, the working prototype is the most important requirement before proceeding with your project, before your interest list, before taking money for your project. You should make sure that you have a working prototype that's completely working, software and hardware and all. I know it's difficult for some projects, but for mine, we had a working prototype that was in place before we started taking money for the project. So with the working prototype, you don't want to get die-cast molds for everything, because that's coming up why you can't do that for a prototype. So you can have a prototype made with CNC milling, with 3D printing, and with all sorts of different things. You can take some off-the-shelf parts maybe for your project. So you want to try to minimize the number of molds you have to make getting your working prototype. I think for this project, I did the barrel and flipper molds because those were most essential, and those were relatively lower cost than the molds for these huge die-cast cases and keycaps and all that. Another thing that I messed up on was make sure your molds are good before you order them. Make sure the parts are actually good. So I had to pay for them to fix a mold, enormous expense, because I didn't measure the barrels right. But that was the big thing. So after the working prototype is when I would say you want to start accepting orders, so people are confident that you can make something that will actually work. Okay, so now some more fun, just quick fun slides. The first thing we did, the big part, after getting enough orders, after a couple months, we got enough orders. So first up is the molds for the die-cast cases. And I don't know if you've ever seen molds, but these are what molds look like. They're enormously expensive parts. Even if your part you think is relatively simple, like a case, no moving parts or anything. Many molds for this project, just to give you a sense, they cost more than a luxury car, just for one mold. So molds are not cheap. Another piece of advice is be aware of whether custom-made molds and tooling are needed compared to what's already out there. So nowadays, a lot of people, you can use like a little Raspberry Pi or other computer to power some kind of DAC or some other device that you're putting together, and you don't need to design, like you mentioned with Google designing their motherboards, you don't need to design that. You can use a lot of off-the-shelf stuff to help you with that. Here's some more photos on the molds. So actually, you could see, like, why are the molds broken up in pieces? So what the factory did to save money was, because the cases were similar, they shared the molds between them. So you only needed a little part on one side to get the two molds. So they saved a little money that way to help the project be more affordable. And this part is really cool. I have a bunch of little videos here. So the cases are made of die-cast zinc. So the zinc, when it cools, it warps. So what they have to do is hold the cases in some kind of jig so that it doesn't warp too much. And some other fun stuff is there's very low-tech processes for some of these things. If the case is a little bent too much, guess what they do with the case?
Throw it away.
No. They take a rubber mallet and they just hammer it into shape. So it's very funny. Like I'll talk about the processes for low volume manufacturing are very labor intensive. There's no automation just about. And the first die-cast zinc cases, this is what they look like before they're powder coated. Another cool video. So have any of you ever seen a big laser cutting holes in super thick metal? Well, here you go. So this is the machine that cuts all of the little holes for each key in the top inner assembly plate. So it does one at a time, I guess, and there are maybe, for a batch of 2,000 keyboards, maybe a couple 100,000 holes they have to make. Okay, here's another interesting one. This is the inner assembly stamping tool and also the inner foam stamping tool. So you can imagine that this is just the tool part, not the huge machine that puts all the pressure into bending a piece of metal to fit that shape. So unlike a Cherry MX style keyboard, which has flat plates, all of the Model F plates and Model M plates are curved, so they kind of fit into each other like a curved sandwich. And this part on the right is the part that stamps, so to help secure the barrels in place inside the keyboard, there's a piece of foam. This is just examples of all the various parts that go into making this kind of project. So these are ribbon cables. I don't know if many of you have seen like an old IDE cable from like an old floppy drive. Some of you are remembering these old building your own computer back in the day. It's not easy to find factories to make the old style ribbon cables, as you might imagine, because there's not a lot of demand, and the tooling breaks and they don't pay for it anymore to fix it. So a similar story with one factory that owned an injection mold for card edge connectors used in the XWhatsit beam spring controllers. Have any of you ever touched a card edge connector? Maybe some of you have. So I remember they told me their card edge connector mold broke, and they said it just wasn't worth fixing it, because no one wanted these card edge connectors. So I had to ask around to find these card edge connectors. So it's a bit of like a search to find manufacturers that are capable of doing all these old school technology things. Okay, now on to like the most complicated molds. These are the molds that make the keycaps. So the keycap molds, why were they started a year after the project? Because there wasn't enough interest to be able to make the keycap molds from a financial perspective. So the original plan was to use Unicomp keys. So you guys know about Unicomp. Unicomp acquired all of the tooling from Lexmark, which was a subsidiary of IBM. So Unicomp still today makes the old style IBM buckling spring Model M keyboards. So since the keys are compatible, the plan was to use Unicomp before there was enough interest to be able to make and do the sublimation of these Model F keycaps. Another interesting thing is you could see there's a little number in the mold. And have you ever wondered why, if you look inside a little piece of plastic for any part you have, why there is a cavity number? And I think the reason is so that they can identify if a part is not being made to spec, they can identify what part number it is on the mold. So these molds they break sometimes, like we had an ejector pin fail on one of the molds, and that takes a while to fix it. So a lot of parts break and you lose uptime for that reason. And another thing is the tolerances are so crazy for this project. Guess what tolerances you need for these keycaps? 0.1 or 0.2 millimeters, plus or minus. So we're talking about a fraction of a millimeter to get these keycaps working so they're not too tight that they get stuck on the keys, or not too loose that they pop off the keys, pop off the barrels. And here's another part. This is a P-clip. So this is a strain relief clip part that was custom made to hold the USB cable in place. So even a relatively simple part like the P-clip requires intricate custom made tooling and an operator stationed at the machine, bending each clip to shape one part at a time for thousands of clips. So you would think, like a lot of people think, like everything is automated, but everything, the key with low volume manufacturing is that everything is far more labor intensive than one would think. It's not a fully automated production line like that would be common for larger things. So I can imagine hundreds of people were directly involved in making and assembling everything that goes into the Model F. There are two different categories of how to bring a product to market. There's either the old-fashioned way that I call it, which is still done today, and also the crowdfunding way, which was done for this project. So the traditional way is you can imagine you're getting investors, you're getting friends and family, you're getting a bank loan, you're using your own savings to start up a business. You're investing hundreds of thousands of dollars for this kind of project or for another project for tooling, or you're getting investment from a VC and giving away some parts of your company for that. So what are the advantages? Obviously, if it's a winner-take-all market and it's a software company and you need, or software as a service, and you need a first-mover advantage, you need to scale as quickly as possible, obviously venture capital is the way to go for. The disadvantages, though, are, I would say, like for this kind of project, I don't think it would have come to fruition, given how small it is, how low the expectations were, and how difficult it would be to expand a physical product with margins that are not software margins. So I would say gatekeeping results in fewer products that can actually come to life, which is why I think crowdfunding is a very interesting development to help get products made that maybe would not have seen the light of day. The crowdfunding way is you're getting a working prototype, and then you can start your crowdfunding campaign. So there's two types. Do people know about crowdfunding here, like equity versus non-equity? Some nods here. So quickly, equity crowdfunding, people become part owners in your company in exchange for the startup capital you need to do whatever you're doing. And my focus is on the non-equity crowdfunding. So in crowdfunding, just for those of you who don't know, people pay in advance with the expectation, but as you know from many news stories, far from a guarantee of receiving your reward or product. So if you've heard of Kickstarter and Indiegogo, these are companies that are crowdfunding platforms. Generally, people use them for physical products, such as electronics, books, and games, instead of services or software. Most crowdfunding is done on a platform, but this project was actually done through the website, through a website that was put together. And the last point is about communication. So with crowdfunding, the big thing, frequent updates, keeping people posted. So in my case, the forums were a big part of the updates, people posting on the forums and talking, posting on the project's website or on the Kickstarter updates page. In terms of that interest list mentioned before, what I recommend is gathering emails for an email newsletter list rather than just opening up a store and saying, I'm here, start taking orders. So then at that time, you can keep people updated and then you can update people when the website's a go, and maybe you can do an email newsletter where you can educate people about the product and why your product is the best. Okay, so now into the fun, controversial stuff about quality control. This is by far the biggest headache with any manufacturing project. So 2 types of quality control. One is essentially getting things right before mass production starts, and the other part is the quality control of each production part and each batch. And this is a nightmare because you have to, no one wants to check every single part. Everyone just wants to assume at the factory that, oh, all these parts are good. The other factory checked them, so this assembly factory says, oh, we're good, we're just going to start assembling them. So that's kind of the challenge. So what things took a long time for the current project? Why did it take years instead of 1 year or a few months like I was expecting? So the first thing is, like with software, I'm sure many of you can publish an update and it's propagated relatively quickly. But when you're working with factories overseas, you can imagine that the turnover time to fix physical errors is very long. Like it may take a while to fix a mold. It may take a while to produce a sample, and to wait for even air shipping might take a few weeks to a month. So the timeline is far longer than expected with products. The other thing, just little things with the project, how to match the colors, and how to match the texture. So what I did was I mailed them the original parts and said, match this, because there's no, like a lot of people think every single color can be a Pantone color, and you can just say, give me this Pantone number on this part, and that doesn't always work out for the old colors and textures IBM used. So another point you might find interesting about the tolerances, IBM's 1980s tolerances plus or minus 0.1, 0.2 millimeters, they were even so impressive that with today's manufacturing, that some factories I spoke with all of the modern equipment of today could only meet 4 times IBM's original tolerance range for the springs. So that's how good IBM was back in the day, that even now a lot of factories can't meet up to the great work that they did back in the day. Other things, making sure the barrels and flippers are all in the right place, because not every barrel gets a flipper, because sometimes you have a stabilizer insert with some of the keys. So, and then just another thing about the quality of each part. We had a problem with the soldering. So they really needed to flood these old ribbon cables and through holes with solder, or else there were some problems with the soldering. And they didn't know that, and I didn't tell them that. So it was a problem. I had to take apart a lot of keyboards and resolder them before they would go out to customers. So that added more time to the fulfillment. So in terms of quality control is so important to me for this project that I personally inspect and fulfill every single order, though the factory does 90%, 95% of the QC work, and I'm just the last step. But obviously, if you're doing most projects that are less QC intensive, or if you're selling 10,000, 20,000 units, that's just not feasible, and you have to hire a fulfillment company. Okay, so here's just an example. So I had to look at 50 different types of springs and test each one to see which one had the closest sound to the IBM originals. I sent the springs off to a material analysis lab for metallurgical analysis of the different elements in each spring. So that was another thing. The tooling would break sometimes. A lot of people try to think like, what's the bottleneck in the project? So a lot of times, entire batches of parts were made wrong, and everything has to stop while they remake those batches because they can't finish with assembly. So that's another thing. Like the springs, like you look at those springs, like the factory thought that was okay, and we had to say, no, you can't give bent springs to us, so they had to remake them. Okay, so here's another cool video. So it took a year or two to figure out how to attach the springs and the flippers in an optimal way to make sure that the springs would have a nice sound and would be optimized with the right angle. So here is one of the early prototypes. So it uses like air suction or pneumatics to hold the flipper in place, and you just have an operator at the machine doing 3 flippers at a time for 200,000-300,000 flippers, and that's how these things were done. A lot of by hand work. And this was the latest machine, the production machine that they did. And this is just an example like of a small number of the thousands of springs that they had to attach to all the little flippers inside.
Joe, quick question, and can you repeat it so the audience can hear?
Oh.
Did they do Was that brought to the US for final assembly, or was that all overseas?
Oh yeah, all of the machines stay at the factory, so I don't deal with any of the machine repairs or the mold repairs. The molds stay at the original factories, which I'm going to talk about in a little bit, about how you got to pick your partner. You can't just take they view it as their mold, not your mold, even though you're paying for it. So you got to be very careful with them securing all the molds. Okay, so here's another machine. You can see they're going really slow, but I'm sure they assembled faster in production than in the video recording. But these are just two more machines that put the plates together. So you need to have them under a lot of pressure, and then they're slid, kind of like an interlock. You could see kind of the interlocking plates that connect the top and bottom inner assembly plates. So I'll just loop it once more, and the guy's going to point to it so you can see what the machine's doing. So it's pushing down, and then there's another piston or something that pushes to slide the plates into each other. So let's play that for 10 seconds here. Yeah, so now he's pointing to it. So so there you could see how the plates slide together. Okay, now here's more of the problems with the world of manufacturing. So why were there years of delays? And here's you can read that there are some of the causes, but there's also an interesting besides the normal things about the insistence on quality control and getting the original specifications right and not willing to accept the factory offering a part that is different from the one you want in terms of the times. Like the key molds, the first supplier actually failed to produce the key molds, and I lost 5 figures on that, and we just gave up and went to another factory. So that was pretty painful. But these factories, they say they can do it. Sometimes they fail, and it's problematic. But another thing is, like even getting the dye sublimation process, I chose, instead of going to a standard dye sublimation company that did these keys, I worked with a factory to get all the processes done from scratch. So all these machines, I had to buy all of the sublimation machines myself. They had to set up workers on it. So it's a whole big thing to get them to learn from scratch how to make the keys up to IBM's original standards for dye sublimation. And just if you don't know what dye sublimation is, it puts the ink into the key so that it doesn't wear down. So like many of you may have a key where on the laptop where you may not see the key anymore after you've been using it. Those are like usually pad printed keys or UV screen keys. But dye sublimation, these keys can still have their legends looking almost like new after 40 years. Although the texture on the top does wear down with usage, you can still see so another issue is all about factory turnover. So this is an interesting thing. The factories have to reteach a new season of workers every year or with every production batch. So it's very interesting how things work. A lot of, not talking about the engineers, but a lot of the line workers at the factories there's a lot of turnover. And the factory tells me the new workers, how to do everything every single time. So you have that, it's harder to find workers, so you can't just hire 100 workers for 1 month to get these keyboards made as quickly as possible. You have to, a lot of them, you have to hire them for the year, and the factory has to plan that out in terms of how the speed to production versus their overhead costs. So that's another thing that is involved with very labor-intensive projects. And here's just a picture of the keys. So I think that this is a wonderful result of something that took over a year to perfect the dye sublimation process. So I think that these are beautifully sublimated IBM XT quality keys that you could use on an old keyboard just as well as a new one. So I think it's definitely worth the time and effort to get things right, at least for this project. Now we're talking about like some of the scary stuff. Like I mentioned, I lost money, and not only the money, but also the time. We lost a year on the keycap manufacturing because they kept saying, oh, we'll fix it, and they just never made enough progress to get the keycaps within the right tolerances. So we had to give up, start over with another factory. So that's why it took a couple years. But the interesting thing that's very scary is the whole lot of fraud and theft in the world of overseas manufacturing. So I'll give you like 2 or 3 examples. besides the keys. Let's see, the other one, we had, remember that simple part, the P-clip for the strain relief? We had another factory, I gave them the specifications, and they sent a completely different P-cap and tried to pass it off as, oh yeah, that's what you ordered. So I had to complain to Alibaba to get my money back on that one. But even just complaining for a few $100s took months of time. So it's really difficult even to get a small amount of money back. So you basically have to understand that wire transfers, which is how you pay the suppliers, they're normally irreversible. But not in my case, in one example that I'm going to show right now with business email compromise. Are you guys aware of did they tell you about the different types of fraud? I don't know if any of you have been purchasing here, but so business email compromise fraud, what they did was they hacked the supplier's email address, they intercepted messages before they were sent out, and then they changed the account number instructions on the wire page, and I sent it to the other account number for tens of thousands of dollars. So like these things, the supplier's not responsible even though their email's hacked. They didn't get the money, so that's not their problem. But fortunately, and this is probably unheard of, every single penny was returned to me, thanks to the involvement and the working of the government and the banks and the different things like that. So it was extremely rare that all of this fraud was recovered. I was very surprised with that. Okay, yeah, obviously communication issues, talking with people around the globe, time differences. You might have to be a night owl to work with different people if that's what you're thinking of doing because of the time difference overseas. And then just quickly about intellectual property, it's tough to get factories, prevent them from making extra copies of your stuff. You see that all the time with name brand stuff being offered for lower prices all over the place, probably made on the same production lines as the official products. So what I do in that case is, as I mentioned before, this project has a whole lot of different factories that are all involved in a small part. So no one factory controls everything required to make a product. Then you have some legal issues. I'm not a lawyer, but just as you know, that as I mentioned before, when you order a mold, the mold is held by the supplier, and you can't really switch out the mold to another supplier. So you want to think hard about how your communication is with the supplier to see if you have a good relationship and if they're quickly responsive for that. Another interesting thing, you would think a lower cost supplier is not always the best, but in my experience, many suppliers offer super high quotations or are slow to reply if they're not interested in the job or are too busy to accept the job that you want at a higher rate. So actually, I found that you may receive better care and attention from a hungrier supplier. So the highest cost is not always the best. Okay, so, and this, I think, is the second to last slide. So the next steps with the project, we have additional keyboards coming out with the beam springs, with the Model F keyboards. Now that there's enough demand, I think, to bring these other products to market. We have over 1,000 people who have signed up for the beam spring model, which I would not have expected. The beam spring is like a very obscure IBM model that was used on terminals in the 1970s. So I can't believe 1,000 people signed up for that. So that's that. These are recommendations and advice, just in closing. So I think your company has made famous the concept of 20% time during work. Quote, working on what they think will most benefit Google, to quote your co-founders. An Inc. magazine article has a good recommendation to apply the 20% concept more broadly. So quoting from them, think of the things you spend time on that broaden your horizons and make you aware of opportunities, potential projects, or help you develop new skills, but that don't relate to an immediate professional benefit. So what I do is I would encourage each of you to take up and develop hobbies and interests throughout your, and see where they take you, because this project started out as a hobby, and now we have 4,000 keyboards in the world for something that I thought might sell like 50 or 100 keyboards. So the cost to prototype something nowadays have dropped significantly, so physical hardware projects are easier than before. And in closing, good luck to everyone, and your hobbies and pursuits may lead you into something bigger than you might have expected. So I want to thank again Tony and Google for hosting me here. And if anyone has any questions, I think we have.
We've got a few.
Yeah, I don't know how the system works.
We'll keep recording until the end. I'll do one from the chat. Someone wants to know if you,
Oh, you got the question?
if you acquired the rights from IBM Lexmark to make the keyboard.
Yeah, so I mentioned in the speech that the IBM patents from the 1970s and 1980s all expired long ago, so there were no intellectual property issues with this company. I don't know if I mentioned it or if it was just in my notes, but so there are no intellectual property issues with this project in particular because everything expired from the patents.
Yeah, so first I want to thank you for doing this project.
Thank you for coming. It's nice to see everyone interested in these old keyboards.
I hadn't been following the newsletter. I didn't realize that you're doing beam spring keyboards as well. I'm wondering if that's still eligible to order, or is that already closed?
Yeah. So on the Google Forms interest page, that people can sign up for them. Yeah, at the project website, or they can Google Beam Spring Reproduction Project and find that Google Form link on the Desk Authority page.
Go ahead, I'm just going back to
Oh,
you.
we got to go to presenter camera, right? Oh, yeah. Yeah, so that's still available. And later on, I brought some keyboards here if anyone wants to hang out and try. I brought a Beam Spring prototype. I brought a Model F prototype. And I brought a Model F 77 compact version because it was too heavy for me to bring the original.
And second, I was wondering if you could talk a little bit about what the plan is or the story is for maintaining these keyboards, 40 years from now and so on. I know you have extra parts and so on that you sell, but a lot of this sort of relies on your expertise and the community's general expertise. Is anybody making a business out of trying to repair these things professionally? Like, say, if I don't want to figure out how to repair them, but I want it to work 10 years, 20 years, 30 years from now?
Yeah, so that's a good point. So my philosophy, I put it on the website, is that I believe that every user should teach themselves how to maintain these keyboards and buy enough spare parts so that they can fix a keyboard in 20 or 30 years from now. So what I do is I have like a first aid kit of different flippers and springs, so if something breaks, you can fix it. I put the videos up online on how to take apart the keyboard and repair it. I have a quality control secrets video. So my goal is not having other people have enterprises to do this, but for each user to be able to be self-reliant on how to fix a spring or how to set it up. Yeah, thank you. So what else do we have?
Things, someone would like to know if there's plans for a full-size Model F?
Yeah, I put that on the slide, but it went away. But yeah, so I have a full-size F here, a prototype. Since it was developed during the times of COVID, this prototype. So this is actually the first in-person meetup where people can try it.
Okay, we'll look at that in a minute, yeah.
Yeah, I brought a solenoid too with it. You know remember the solenoids? Anyone in like really old 70s computers? So I brought a solenoid as well. So whenever you type a key, the solenoid fires off. And I wouldn't have believed, but 1,000 people have bought solenoids for their keyboards to make them even louder.
Someone wants to know if you can make a Model M15 with a Model F keyboard technology.
Yeah, I put it. Yeah, I put it on the. Maybe they didn't. I didn't have the slide up.
That might be.
But let's see if I can go back to. Oh, here it is.
There's another.
Yeah, so the plan is to have the standard style models for people who don't like the ultra compact models. I have the M15 style. A couple people asked me for that, so I'm making that. And also ortholinear. A couple people are interested. I don't know, do any of you guys use like split ortholinear keyboards? I see a couple.
Any chance of a split staggered?
Yeah, the M15 is the split staggered, and the Ergodox style is the split ortholinear. So they're both split. And then I have a macro pad too, so that answers that one. So yeah, those are coming up in the pipeline. But my goal is obviously now that I've mailed out all these originals, now I could focus on these other projects like the beam springs. I don't want to start a new project but now this project's 99% shipped.
I have a question. So have you ever considered like making a modularized switches like that feels and sounds like IBM keyboard?
Yeah. So people have looked into making they on eBay you can buy like a little switch tester, but people have looked into making IBM buckling spring individual modular switches, and they've done like Kickstarters and other things for that. but they've never come to fruition. The problem is that the Model F is based, the whole experience of the Model F is based on how the parts reverberate and sound against each other, and how you have a metal plate, and how everything is very well built and easily repairable. You don't have individual switches soldered onto a PCB board that may fail in the future because the soldering is all exposed on there. So with the Model F, everything is capacitive. It's all sealed inside the solder mask. So I would think that I would not think that I would pursue that just because the longevity wouldn't be there, maybe, or the interest. I don't know. So any more chat questions? Oh, we got more questions. That's good. Any chat questions?
More questions from the floor. People want to order more.
Oh, yeah. So the orders are still open, and a new container ship is coming out. The 4th container ship is arriving in a month. So I forgot to mention this, but there's a change in the trend in the project. So before, everything was being made to order, and people would order, then I would take the funds and give it to the factory, and they would place the order. But a lot of people complained that it took too long that way. So
the next question: how long will an order take?
Yeah. So the new change is that I ordered a whole bunch of keyboards ahead of people ordering in all different variations, over several dozen variations. So now when they arrive in a month, I'll be able to ship them out right away, and you don't have to wait for your keyboard to be manufactured anymore. So that may help people who need something more urgently.
All right. Well, I'm going to thank you, Joe. It's a pleasure having you
Thank
here
you so
today.
much, Tony, for inviting
Yeah,
me,
let
and
me-
everyone for coming.
We'll
Do you
share
want
the
me to-
slides later. I just am going to stop the meeting, and thank you everyone for being here.
Yeah, so if anyone wants to hang out, anyone in person, I guess, I'm going to take out some keyboards if you want to try them out or take a look at them. Or if you have to get back
Yeah.
to work, then you have to get back to work, right?
Exactly. Yeah, well, no one's working today. They came out to play. All right. Bye-bye, everyone. Thanks.
Thank you for coming.